And now, ladies and gentlemen, we have the next an address. Once again, we understand how universities need to reimagine themselves, reinvent, adapt themselves for an era which is defined by technology, global benchmarks, and continuous transformation. I would like to invite our eminent speaker, Dr. V.S. Kanchana Bhaaskaran, the Vice Chancellor of VIT. 4 decades of experience across teaching, research, and academic leadership. She, ladies and gentlemen, has played a pivotal role in advancing academic quality, research output, and the integration of technology in learning.
Yeah, good afternoon all. Within 10 minutes, I'm supposed to be completing the presentation. So I will just go a bit faster. So why reimagination is urgent? The rigid curricula and exam-centric assessment what we are having, and the rapid technological disruptions what we find, they make it very important for us to go for the reimagination of the curricula and offering in higher education institution for the tech-led future. Skill gaps, what we are finding, industry says the students are not skilled and we have got to take care of that. And the global competition for big tech talent, that is there. And we are actually having the maximum tertiary age population, and for them to find employment, and unless we convert their numbers into actual employment categories, that is going to be chaos in the country. And university is an important node in the national innovation industrial ecosystem as a very important part of it, a node. We have got to be very careful in that in higher education institution. And above all, we have AI, automation and digital platforms, all are there in front of us and all are very easily now available, accessible to everyone, and we have to make use of that. So as a university model which is reimagined as per the requirement, what should we do? It was actually told also, academic, administrative and financial autonomy is a must. And moreover, we have got to have flexible and learner-centric universities which makes the student to learn, and as was also pointed out, inter, trans and multidisciplinary approach should be there for the students to learn, so that they are holistically useful for handling that sort of applications what are coming up, and stackable credentials and credit mobility, so that the students feel enthused and they feel directed to go after their own interest, which I will show with an example also. Outcome and competency based assessment, which has to be changing, not just written examinations based on that passing the students, and research intensive, because the students more than whatever they study, they have got to think also, they have got to understand the needs and they have got to do research. And research partnerships in silos, it cannot happen, in silos among the researchers, in silos between industry and the institutions also, all these are to go together. And quality over quantity, I am putting it a question mark, because for our population, we feel that as per our Chancellor's input also, always he used to say, for country like ours, we need to have quality and quantity consciousness also. There is no other go, because that is the requirement. So curriculum re-architecture, how from the perception of a student, how will it be? Industry co-design dynamic curricula. I say dynamic because every year based on the requirement we should be able to change it. As a university we are able to do, but every other institution also given with autonomy, they have got to do this. So industry should be there in the industrial advisory board, in the board of studies and in co-teaching, I am putting that. Strong foundations the students should have, without which the grasping is not going to be in full. And alignment with emerging technologies, interdisciplinary majors and minors, I will show this in a later slide. Mission driven yearly projects also for the student to have hands-on experience. In addition to just rote learning, we have got to have this as a very major component. And live industry and societal challenges, even inside the labs, they should happen. Not just in projects, not just typical experiments we should have in the laboratories. Research innovation credits, prototypes and startup pitches should be encouraged in with the students. and the students to spend, that's what I told, 50 to 60% of their time on real tech problems they should spend their time in addition to just learning it. Embedded internships and co-op, credit bearing co-ops should be there, and which we practice actually, which is giving so much of good input. They should create great digital portfolios. The employers should seek our students for their recruitment rather than be applying for a job. And the faculty for a tech-led future, how should they be? How they should use industry as a strategic partner. Scaled FDPs, which are very important. And for institutions like ours, where we have 3,000 faculty across the 2 campuses of university, we need to have this sort of a model. This is where co-teaching should be there among the faculty, team teaching should be there, because the subjects are such which has got to be fed by different expertise, and joint mentorship also for projects, so that my input and the other input should go for making a holistic product. Guidance and industry collaborators should be there, joint branding and research credits are to be part of it, and sabbaticals for the faculty members we need to give, and industry externships, they should go to the industry, short term or long term also we should allow, and faculty student industry immersion, this should happen. We should go to the industry and check what problems, what concerns they have got, which we can go for solving in the university, and incentivize the pedagogical innovation among the faculty members whoever are following that, so that more faculty would go for it. It is not just a job which goes for it, teaching is more than that. And startup and IP industry mentors we need to have from industry and from faculty together for the students, and multidisciplinary project demos and design reviews should be there for the students by the faculty members and the industries who are going to be the people who are going to be recruiting them. For a typical example, mechanical engineering curriculum at VIT, how we have is university course 60 credits and professional course 60 and open elective 40, out of which we have got baskets of physics, chemistry and all, and we have got projects there, and the program core is there, and here we give concentrations in which area of mechanical engineering the student would want to pursue, and those concentration 1, concentration 2, concentration 3, 4, we go for giving opportunity for the student, so he gates based on his own interest, he can go for taking. And all courses, the open elective courses, 25% of the credits are given for here, 40 credits we have given. And the primary features of our curriculum is concentration with be allowed, and ancillary, a multidisciplinary set of baskets, which would be for an electronic student or a mechanical engineering student, they can go for robotics, AI in robotics, automation and all that. Minors we give as per AICTE also, and honors we allow them. And a second major with the additional, the credit mobility in this direction we are engaging. A second major the students can do, in addition to ECE major, he can go for computer science also. And this is the particular thing what I said about hands-on. The first year they would be working with the projects, and the second year, third year individual projects and technical answers for real world problems. This makes the students throughout the year engaged, and these students can go to any faculty across the schools, across the research centers for guidance, for mentoring, and no faculty can go for rejecting, or the students with their interest they can choose anyone based on their problems. And as per NHQF, we have 160 credits, or those things and all we follow, and multidisciplinary education and physics, mathematics, ethics and all, as per the program we go for giving. And the policy enablers, how to have in the universities these things enabled. What are the prime movers for that? IT infrastructure should be there in the first phase. Second phase, comprehensive faculty training is to be there, and student success systems, for example, the proctoring, whatever inputs the students need, that we have got to give also. And flexible curricula, it has to be accepted by the Industrial Advisory Board, Board of Studies and all, and industry participation right from the laboratories, right from the projects, right from co-teaching as a professor of practice into the university. All these are to be there set. And research and innovation funding, there should be no limit for the funding based on the problems, based on the number of students who are doing. We have got to encourage them, only then it would open up, their ideas would open up, and we will be able to validate whether the student succeeds in the project or not. We have got to attempt. By failing also, you would have learned something. Because we have done something, it's not actually working. So what is the other way to get it right? So the research and innovation funding and all is very important. And faculty workload, the workload is not just 2 theory and 2 laboratories and all. In what way we have got to make the faculty very productive, and the students finding it extremely useful for meeting the market demands. That we need to do. So research and innovation for national impact, AI tools are there nowadays. So we need to have for curriculum design and content creation only as a tool, but not using the AI for replacing the faculty as it is. And adaptive learning and automated assessments ought to be there when we are using AI tools naturally, right from the students' attendance, right from the behavior of the student in coming late to the class or absenting himself or not performing across semesters. Everything is nowadays possible, and we will be able to take care of each and every student. We can monitor them and give sufficient input through the proctors, counselors, through the course teachers, HODs and all. So the automated assessment and adaptive learning, these are going to be giving so much of real potential. And recognition and incentives for innovations in teaching, mission oriented research clusters, because we identify across schools not only the makerspace laboratories, we identify the laboratories, we make it open for the students to go for registering for whatever projects they do. The faculty members say that these are the facilities what we have available in the laboratory. You can all, if you have these sort of problems to really solve, you can come and work on that. That we are opening. Actually last week we have got one associate dean of UG research. He opened up, he sent a mail to the students. Within one day evening he got 1,000 responses from the students. Such is the reception from the students. But the higher education institutions and the teachers there, we have got to really make the thing happening. And research clusters 1 and industry funded laboratories we need to have, so that the industry concerns are coming to us, the industry for their higher education they come here, and therefore upskilling also they come here, for their MTech and PhD programs they come here, so that our faculty and them, we have good research scholars and facilities, the latest simulation tools and the latest facilities what we need to have, testing facilities and all, and they have their requirements. So let us all meet. And that meeting between the industry and the institution, we want the foremost in the country. That is of utmost important. In university-led deep tech startups are to be encouraged, centers of excellence, and the measurement. If we are implementing all this, how are we going to really see the impact? How do we go for measuring it? The first one would be student employability index and average. It is not just getting employed only in IT companies. How many core companies he is approaching, what is his experience, expertise, what he has got, like our program outcomes and program specific outcomes what we measure. There we should be able to see in what area the student has gone also. The impact of whatever we follow. And average portfolio growth of the students and startups, incubation projects, how many we have launched, and patents and industry joint innovations, and faculty industry sabbaticals. Actually in industry joint innovation, so many consultancy works would be going on. But the consultancy work, it should be ideas from the faculty members with respect to the requirements of the industry. That is the reason why we say that externships for faculty would be important. They should go to the industry, stay there for some time, observe and bring out the ideas. And faculty industry sabbaticals to be completed, that is an outcome. And industry co-authored publications and product releases what we have, including the technology transfers and joint labs in campus and industry centers of excellence. Nowadays companies are really opening up, right from Renaissance, right from all the FPGA companies, they are all bringing their development kits and trainer boards and all to the universities, they are giving. but we are not actually opening it up to the students. We should open it up right from the first year itself. We have got to make the student do an application project with that and see the results. And there, if we open up the student's mind to receive and to find out, to identify where he can actually go for using what, the problems what he is seeing. As a teacher, I cannot give 60 students all the problem statements, but the student, when he goes out, when he sees around, he would be identifying excellent problems. Our duty is only to guide him, mentor him. So, joint labs in industry, and that would actually expose him to the industries also, and the industry directly contacts the students straight away, and the excellent projects can be coming up. And the regional skill and innovation clusters, as a big university, as a multidisciplinary university, it is our responsibility to go for catering to the institutions around in our district and beyond, for enabling those teachers, for enabling those researchers and students, UG, PG and all. So, such innovation clusters are good. And India right now, we have so many government initiatives, I need not tell you all. India Semiconductor Mission has come up, a National Quantum Mission, and cyber physical systems, which actually covers right from Industry 4.0, every AI, robotics, everything, including cyber security, which also is a very major important component of what we require in the country. And the India AI mission, we all of us are always talking about it. And the NSM, National Supercomputing Mission, it is an excellent thing, and we had been meeting there in one supercomputing, the first conference what we had in the country, and a natural manufacturing mission. It about covers everything. And here we have everywhere, the semiconductor is actually playing a very major role. Whatever be the areas what we have got so far, whether it is mechanical engineering, electrical, civil, or whatever it is, we need to have the semiconductors, and more than oil import, we are going to be importing for semiconductors, so that should go away. There are several missions there, right from devices, packaging, but what we are strong, if we are having 20% of the total designers in our country, we have got to focus on such aspects also. And robotics, sensors, IoT, instead of importing all the control mechanisms, all the IPs and all, right from automobiles, right from our robotics and all, we have got to make it here in the country for high power electronics, right from that. Because there we do not need very low technology nodes, even high some 220, but 250 nanometer technology also can do, 180 nanometer of SCL can do. And our students had gone for five designs in one IC, a 40 pin IC manufactured here recently in SCL, the quantum naturally. And the closing message what I would give is, the universities should act as the national transformation engines, and the collaboration across government, industry and academics will take it forward, and all of us, all the three should be receptive to the other's ideas and should coordinate, should sync well and focus on quality, relevance and impact. We have so many students and we have a tertiary age population maximum. Unless we guide them properly, unless institution like all of ours focus on such students, it is not going to be good for managing so much of energy among the students. It will lead to chaos. So, let us best direct them properly. And build a future ready learner, and the technology missions are our opportunities whatever government also has given. Let us all cooperate, and the universities are the engines, and this is our research blog. So, thank you for the time. I think I haven't taken more than 10 minutes. I took it very fast.
Thank you so very much, Dr. Bhaaskaran, for that presentation and why universities need to reimagine and how. Thank you very much.
Thank you.